This is practice A for section 6.5. We're going to look at numbers 11 through 17. We're going to use the figure to match the segment with its length. How long is it from G to F? You can do this without separating the picture, but it makes it a whole heck of a lot easier. So I took some time, I redrew this little triangle, and I put its lengths on. Same thing with this medium-sized triangle here, triangle AFC. Notice how A to C has a length of 10, 4 plus 6. Triangle AED, this right side has a length of 14. You're just adding those three numbers together. That'll make it a little bit easier when you're writing proportions, trying to solve for lengths. How far is it from G to F? Well, you can use the separated triangles, but you don't need to. You can use your triangle proportionality theorem. You want this distance. 6 to this distance equals 4 to 6. And you would cross multiply here. 6 times 6 is 36. 36 divided by 4 is 9. Let's find the distance from F to C. Now here's what you got to watch. F to C is an entire side of this medium-sized triangle. That's this guy. So what you don't want to do is compare him to part of a side of another triangle. So look at the little triangle and look at this medium-sized triangle. Compare the corresponding parts. 4 to 10. That's the same thing as 5 to the thing that you want. Then you're going to cross multiply, solve for the distance from F to C. 10 times 5 is 50. 50 divided by 4 is 12.5. Let's find the distance from E to D. That's the bottom of the big triangle. So again, we'll compare that to the small triangle since we know all the sides. 4 to 14. I'll come down here, I guess. That compares with 5 to the distance from E to D. Cross multiply. 5 times 14, that gives you 70. 70 divided by 4 gives you 17.5. F to E, I'm assuming that's going to be 6, but we should probably check it. It's always a good strategy anytime you're doing matching or multiple choice. Even though there's one option left, make sure it's the correct one because maybe you messed up somewhere else. So we know this guy is, what do we say? F to G is 9. Well, what's this guy? Well, we can do this to this equals this to this. That's your theorem 6.6 with the 3 parallel lines. So we'll do that one over here. 9 to segment FE, that length, that's the same thing as 6 to 4. And then we're going to cross multiply. 9 times 4 gives you 36. 36 divided by 6 gives you 6. Okay, number 15. That's theorem 6.7. You have a ray bisecting an angle of a triangle. When that happens, here's a ray or a segment bisecting an angle of a triangle in all three of those. What happens is this to this equals this to this. So 6 to 3 equals something to 3. This to this equals this to this. 12 to 8 equals 9 to x. Remember, that's the same thing as A to B equals C to D. Same kind of thing over here. 6 to 3 is going to equal x to 5. Write a ratio of one of the sides that's getting split with the side that it touches. 6 to 3. Here's a side. Here's the side that's getting split. Okay, so 6 times 3 is 18. 18 divided by 3 is 6. 8 times 9 is 72. 72 divided by 12. That'll be your answer. And that gives you 6. And then this last one, I don't even think you need to cross multiply here. 6 divided by 3, that's 2 to 1. So x has to be 10.